Okay, so now that we've learned how to do these things, we're going to start encoding and decoding. Now the first thing we're going to need is we're going to need a variable called an alphabet, but it's going to be a constant. So when I create variables, this is really important. I name them things like bigger underscore number equals 3, 4, 5, 6, 7. Okay, that's a variable. And I'm sort of saying I'm going to be able to change this number. And when I use the program, when I write variables like this in lowercase with a space between them, if it's a two-word variable, I'm basically saying it is a variable that can change. But I also have a method for constants. So constants I put in all caps, just to remind me that it's a constant and it will never change. So my alphabet equals the string of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So this is a constant that will never change. All right? So that's the first thing I'm going to do with my Caesar cipher. Now the next thing I'm going to do is I'm going to say, what is the message? Message to encode equals quotes, so this is a string, and it's going to be in all caps, snowy snowflake. Okay, and it's all going to be one word with no spaces. Next, what I'm going to do is I'm going to come up with a amount to amount to shift. So the shift amount, shift, not in caps, shift equals 1. So I want to shift by one character. All right, so here's what I'm going to do. I'm going to say 4 letter in message to encode. So it's going to go through each one of the letters. The first thing I'm going to do is I'm going to say, I'm going to say what number. I'm going to create a new variable called I, which I'll just use. When I use I, J, or K, it's just a number I'm going to use over and over again. So first I'm going to set it to 0. And I'm going to say 4 letter in message to encode, set I to alphabet dot index and letter. All right, so what this does is it basically says I'm going to set I to each one of the letters in snowy. So snowy, snowflake. So the first thing it's going to do is it's going to say I equals wherever S appears in this list. So S is that A is 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is going to set I to 18 for the first letter in this message. Then what I want to do is I'm going to say I equals I plus shift. Okay? And now, so that would mean that the letter S is going to be 19, and then I'm going to say print alphabet I. So what this is going to do is just going to shift, it's going to print one letter from alphabet, and it's going to print the new I. So let's see what happens. Okay, so the first letter, instead of being an S, was now T, and I think it worked, but one way to show you that it worked is to change the message from snowy snowflake to A, okay, 5 A's, and it shifted it by 1, B, 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 B. But it's kind of weird that the message is printed 1 on each line. So instead of doing that, I'm going to have something which is encoded message equals an empty string. And instead of printing alphabet I, I'm going to say encoded message equals encoded message plus alphabet I, and this is going to build a longer message. And then I'm going to say print the message in code is print encoded message. Right, so let's go ahead and run this now. So the message in code is B, 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 B. What if I shifted it by 2? C, C, C. Okay, so far so good. What if I shifted it by 3? Good. Now let's check out what happens when I do this. What if the original message is Z, 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 and I shift it by 1? What I want it to do is become A, but if I run it, I get an error. And my error is string index out of range on line 11. So I'm calling alphabet 26, and 26 is over the Z. There's nothing out this way. So what I need to do is I need to use that modulo thing. So I have to say I equals I modulo 26. So this will say what's the remainder after 26. So I can go around the alphabet. So let's take a look now. And it says Z, 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 Z shifted by 1 is A. All right, so let's see if it works. A, B, C, D is going to shift by 1. It should become B, C, D, E. Let's run it. B, C, D, E. If I were to shift it by 2, it would become C, D, E, F. Let's run it. C, D, E, F. Okay, and I have created a working Caesar cipher with this technique. So this is a pretty easy Caesar cipher. We're going to make some improvements to it. The first improvement I want to make is what happens if somebody gives you a lowercase thing, A, B, C, D. So that's all lowercase. Let's run it, and it gives me an error. The reason it gives me an error is it keeps looking for, it says where in the constant alphabet does little a exist? And obviously little a does not exist in there. So one thing I need to do is I need to make my encoded message all uppercase. So there's a way to do that actually. So you can just go like this. Message to encode equals message to encode dot upper. So this function here turns it into an uppercase word. Okay, so that worked. Now, what if the message to encode included spaces? Remember, it makes sense to not have spaces because let's say you had a message like this. I am mad. So you can tell where the words are because of the spaces. You really want the message to be a run-on, like I am mad, with no spaces. But if I run it, it's going to give me the same error because the substring space is not found in the message. So I need to actually get rid of all the spaces. Now, I don't remember how to do that. There might be a function for stripping out all the empty spaces. So I'm going to go ahead and look, which is, I'm just going to type here, I'm going to say how to strip out spaces from a string in Python. So I wonder if there's a function for it. Remove all white space in a string. Okay, click here. All right, so def my handle, hello Apple, sentence strip. Aha! Okay, so it looks like there's a function called strip which takes out the white space. But that only eliminates the white space on both sides of the string. So it takes out this white space and it takes out this white space, but it doesn't take out the white space in the middle. How do I remove all the white space? Let's see. Hello Apple, this is not a duplicate because it includes white space and otherwise it's post. Okay, here we go. Sentence strip, hello Apple. If you want to remove, okay, string.replace sentence. Aha! So this thing right here is going to do it for me. It's replace. So if I have a string, like hello Apple, and I replace this with this, that should work. Okay? So let's see if that works. I'm going to copy it, Control C to copy it. I'm going to go back to Trinket, and I'm going to go here, and I'm going to say, I'm going to paste it in, All right, so I don't need this. And it's message to encode. Message to encode, replace this with this. Let's see if that works. Boy, is it going to work? Who knows? Find out. Okay, it did not work. So I wonder if it'll work if I do this. Message to encode equals message to encode replace. It worked. It worked. It worked. It worked. It worked. It worked. So this is the way to strip out the spaces right there. Okay. So now we have a functioning program which allows us to have a Caesar cipher. Except it would be really nice if the message to encode could be entered by the user. So let's go ahead and do that. So message to encode will start like this. And then we're going to say message to encode equals, nice to set up your variables first. So what I did here is I set up the variable as an empty string. So now I'm going to say message to encode equals input. What would you like to encode? Okay. And then I'm going to make it all uppercase. And I'm going to strip out any of the spaces. Okay. Then my next message is shift equals 0. So I set up the variable, and then I say shift equals input. How much would you like to shift your message by? Okay. And then I'm going to get rid of this. And encoded message equals that. For I and message to encode, this works, this works, works, works. Okay, so you asked me to encode, comma, message to encode, print by shifting characters, by shifting shift characters. The encoded message is and then encoded message. All right, let's see if it works, shall we? All right, run. What would you like to encode? I'm going to say Snowy is a dog. How much would you like to shift your message by? 0. I want it to not shift at all. Let's see what happens. Darn. Okay, unsupported operand type for add int and string. Oh, shift equals input. How much would you like your shift to be? But that's a string, so I need to turn it back into an integer. So shift equals int shift. Okay. What would you like to encode? Snowy is a dog. I'd like to shift it by 0. You asked me to encode Snowy is a dog by shifting 0 characters. The encoded message is Snowy is a dog. Okay, that ran. Perfect. All right, what would you like to encode? A, B, C, D, E, F, space, G, H, I. Okay, and now I'm going to shift that by 1. Shift it by 1 character. You asked me to encode A, B, C, D, E, F, G, H, I by 1 character, and I got B, C, D, E, F, G, H, I, J. So we have created a true Caesar cipher, and it works. Now there is one problem with it though, and this is called error checking. What if the user doesn't do what you expected them to do, right? What if they put in numbers or something like that? So I'll run it again. What would you like to encode? Snowy, help, exclamation point. Okay, that's important. And I like to shift it by 1. And I get an error because exclamation point is not in alphabet. Okay? So how do I get rid of every space or every item that's not in alphabet? Maybe what I want to do is something different than this here. Because what this is doing is this only replaces spaces with non-spaces. So let me show you how I'm going to do something a little bit different, which is I'm going to say, instead of this line, I'm going to say 4-letter in message to encode. If letter in alphabet, then hold on, I need a new variable here. Message to encode. Okay, and I'm going to have another string, which is string to temporarily. Let's see, I'll make it shorter. A string equals. Okay. So 4-letter in message to encode. So I'm going to look at every letter in message to encode. If the letter is an alphabet, then I'm going to say a string equals a string plus letter. Otherwise, it's not going to do anything. And then at the very end, I'm going to say here, because it's going to leave this for loop, I'm going to say message to encode equals a string. So what this does is this thing right here strips it all out. Okay. Now this is an example of a really good function. So I'm going to create a new function called def function, or def, it's going to be called def strip char, or strip. That's fine. Def strip. And what it accepts is it accepts a string, and that's it. Okay. And what it's going to say is it's going to say 4-letter in the string that you pass it. If the letter is in the alphabet, then a string equals a string plus letter. Okay. A string equals this. That means I don't need it here anymore. So I'm just going to use this thing a string in the function. So it's going to make a long a string, and then at the very end, it's going to return a string. So this is a function that accepts a string, and then it goes through the string letter by letter by letter, and it makes sure that it's in the alphabet. Otherwise, it strips it out. So this basically just strips out ancillary characters. So now I can say, and we're going to put this function all the way at the top. So I'm going to cut all this, Command X, put it at the very top. So this is going to be a function called strip. Right, so my message to encode is that. What would you like to encode? And I'm going to make it an uppercase. Actually, I should do that in the string too. So a string equals upper equals, how do I get the upper again? String dot upper. Okay. And instead of calling this a string, it's a little confusing to have string and a string, I'm going to call this fixed string. So I'm going to fix it. And this is called fixing. That's what my function is. Fixing. Define fixing. So you hand it a string. First thing it does is it creates this new variable called fixed string, and it takes what you handed it and it makes it upper. Next thing is it looks through each letter and it strips out any letter that is not in the alphabet. And then it returns fixed string. Okay, so let's see if it works. Ready? Whew, that was tough. Okay, so message to encode equals this. message to encode, what would you like to encode? And then I'm just going to say this, which is a message to encode equals fixing message to encode. Okay, because this is going to do all of this stuff. All right, ready? Here we go. If letter in alphabet, bad input. Oh, I forgot to indent this. This will be indented. Okay, let's try again. What would you like to encode? I'd like to encode help with an exclamation, or hello with an exclamation point. Okay. I'd like to shift it by 1. Okay, substring not found. What did it not do? If letter in alphabet, fixed string equals fifth string, plus letter, return fixed string. This is the part that's not working. Index. Let's try a little bit something simpler. Let's go AAA, and then I'd like to shift it by 1. Okay. Oh, weird. Check it out. You'd like me to encode AAA, but then what spit out was 6 A's. Okay, that's interesting. Why would it do that? Okay. What would you like to encode? I typed in AAA. Then it says equals fixing message to encode. Fixing takes the string, makes it into uppercase. 4-letter in string for each letter. If letters in the alphabet, fixed string equals fixed string. Oh, that's the problem. Okay, this is the issue here. String equals string.upper. So otherwise I was doubling it. Okay, here we go. Let's try it again. AAA, little-case, lowercase. Darn it. Local variable fixed string reference before assignment. Fixed string. Oh, I still need to create a new variable called fixed string equals. Okay. I'm going to try AAA. How much would you like to shift your message by? 1. Okay, you asked me to shift AAA, encoded message BBB. Okay, that's good. Now I'm going to try run AAA, exclamation point. I'd like to shift it by 1. Yes, it worked. Oh my goodness, it worked. It took out the exclamation point. Okay, so if I hit run, Snowy is a cool dog. Okay, lots of exclamation points and spaces and everything. I'd like to shift it by 1. You asked me to shift Snowy is a cool dog. It stripped out all the spaces in fixing, and it shifted by 1 character. Wow. Okay, now I know there's a lot going on here. What I would say is, do you understand everything that's happening in this? Go through it line by line by line. Really understand what's happening. Let's go ahead and do that. So I'm going to type AAA, and I want to shift it by 0. Okay, let's see what happens. So the message to encode starts with this, nothing. Then it says, what would you like to encode? And it says, what would you like to encode? And I set it to lowercase a, lowercase a, lowercase a. Then it goes to fixing. Then it goes up here. Fixed string equals something empty. String, which is what I passed it, AAA, equals string upper. So that now turned it into capital AAA. 4-letter in string, so I'm going to go through them letter by letter. For the first A in the string, if the letter is an alphabet, which it is, then fixed string equals fixed string plus letter. So now fixed string goes from being empty to being the letter A. Then the next A goes through this again, and it becomes AA. Then it becomes AAA, and now there are no more letters in string. So I return fixed string, the message to encode, is there, did that. Okay. Then I have shift. How much would you like to shift it by? Okay. And then I've got I equals 0, encoded message. So I've handled error checking, at least in the word that I want to encode, and I'm able to shift it. So you can actually send messages to people. Run. What would you like to encode? Mr. Maltzman is so not cool. How much would you like to shift your message by? 3. You asked me to encode Mr. Maltzman is so not cool. By shifting 3 characters, there's the shifted message, and you have created a Caesar cipher. It would also be nice if you could decode something. I'll show you how to do that in the next video. But this you've created, if you do this, you've created a functioning Caesar cipher. So I'm going to go ahead and retitle it. I'm going to call it Simple Cipher. I'm going to save. And I have a simple cipher up and running. Okay? Hopefully you understand that. Whew. Confusing? Maybe a little. Just go slow. Make sure you understand each step. Ba-boom.